This is Rashia. Thank you so much for joining. And in this video, we will look into another important topic within Python, and that is file read and write and also function. So I really hope I can cover all these three in this single video. Anyway, let's get started. So the program that you're seeing here, it demonstrates file reading and printing its each line in that file and an input file. Okay, so let me explain you different parts of this code, and then of course you can pause the video and play with this type of code. Okay, so if you look at there is a variable where program.s name is stored. This is going to be our input file that we will read and display each line. So then we display a message that okay, we are going to process that file. And then you see this code try. This kind of aligns with this except code. So this, if there is any trouble opening that file, then this code will be executed. This is also similar in other languages such as Perl. So, if there is a problem, then, we kind of get into this code and we actually execute this. All right, so right now this program.s doesn't exist. So if I run this code, and it will not do anything here because the input file doesn't exist. Now the important thing after try, I mean you can give yeah, you can all right, sorry, you can start with this line and with, that's a keyword, and then you open what, this file that we could have given 1 second. If we do this like that, my file, yeah, okay, okay, and then this suggests that we are reading this. Okay, you can also put W for write and A, I think, for append. And this is the variable that you want to give it yourself. So it's saying that open oh God, open this file, and then the object that is open, actually it goes into this variable. That's your own variable, right? And once we get here, then we do iteration over it. We iterate over it, and every time we read one line, then we move to the second line, third, and fourth. Now the beauty of this thing, this enumerate, is the line number. Every time we pull a line, its line number will come into this. Okay, and each line from that file one by one will come into this. Okay, and then we execute, then we process that line. There's only one processing done. We simply process it and then we print it. If you know per language, there is a command there, I think it's jump, that if you have an input line, if there are before the first character there are a lot of white spaces, then we want to typically remove those, and any white spaces that you have after the last character in that single line, you want to remove those. So that is called leading and trailing white spaces. So we typically want to remove, right? They don't have any value. So what typically the core content is really there's a text or numbers or special characters or whatever inside there. That is your text of interest. So you really want to grab that, and here you have just one function which does both things. It removes leading and trailing white spaces. So you execute that built-in function strip on the line and give the output to this variable, and then you just print this as well as you print this. That's all we're doing here. Okay, simple, easy, right? So execute this one, and right away it gives you this message, because actually we don't have that input file. So let's create that file. So you go here, click here, right click here, new file, and let's create program.s. Create it, double click this, it will open another tab here, and I'm going to put a content which is already created there. Okay, this one. We will be processing this later on, but right now, as you see that we have, okay, let's go back here. Let's get it up so we got more space here. All right, let's execute now. See, now it has line number, this line number 1, 2, 3. There are 5 lines on this file, and it has displayed every line. So we're not doing anything else. So for example, you see there, these are white spaces, but when you display, all those white spaces are gone because of strip. Understand? That's clear? All right, let's move on to another code. Put here, and I already practiced these codes separately so that I can save time, and I'm going to bring that over here. All right, let's jump to this one. So do you understand this? You remember this one? This was the regular expressions that we studied last time in the previous video, so you should be familiar with it. So what we are doing is, if you look into this, so we open this, the same file, we go over the file, and this time I'm not using enumerate or line number. So, but we're still using line.strip, okay? And we are making use of what we did in the last video. So we're searching for a pattern on each line. And what is that pattern? I defined it here. So actually, let's do 2 digits and 2 digits. I'm looking for a particular date form, right? 2 digits here, 2 digits here, and 4 digits here representing year. So if on any line has that format of the numbers, so look into this input file, which one has. If you look at this, these are 3 numbers. This doesn't have. Yeah, this one has, right? So once it finds a pattern, if it finds it, this returns true. If it finds, then we just print, hey, pattern found, and then break. That is what we are not processing more lines anymore. That's it, we exit it. And this is also Perl has a break. This is an important concept. So I wanted to get you familiar with, okay, this is the typical scenario in chip design or physical design. Most of the scripts that I wrote are doing what? They read reports or they read logs. Either I want to extract information, put in a different format, or I just want to extract a certain information and display that. And I don't want to, for example, linking errors. I'm looking for a particular errors. Or I'm in the report file, I have a timing report and I don't need all the information. I'm looking for a slack, arrival time, data path delay, capture, clock delay, stuff like that. So I just display that in a CSV format. So those are the type of things we do. So we always look for a pattern on the line, and if we find it, we exit, we move on to the next timing path, stuff like that, right? Or the next time, next file. So that is what I'm modeling here. So one is done and it's gone. Let's see, let's run this. So you see that it printed first, didn't find the pattern, printed this one, then it went to this line and say and it said found a pattern, match for the pattern, and left. Good, understand? All right, so let's do another one and a little bit longer one, and now I will introduce file writing as well as function. So let me copy this thing. Sorry, another thing that you don't see, but it's a longer code. Okay, this is another example. And what's happening now? So let's carefully look into this. Let's make this bigger. Hopefully you can see this. Okay, So here we have two functions. This is one function. This is how you define a function. So we have created get arithmetic opcode. So basically we will bring a mnemonic like in add, subtract, and so on, and this will return, this function will return the opcode, right? A scenario that we would be implementing in our simulator assemblers. Okay, so this is the sorry, this is the entire definition. Right. Function is here. Okay, so this one is, and then what we do here is, did I do this correct? Yeah, we're returning this. All right, so then you see here is our main. I mean, we don't have to create main, but you know, typically you will see in the file. Oops. So we created file, and our execution basically starts here. This standard Python constant show that main runs only when the script is executed. So whenever we execute the script, this will execute main. So it will come into this and we will start executing it. Okay. So this our main code starts here. So what do we do? Let's quickly go through it. So we need an input file. This arithmetic program.s. We haven't created that. And the program will create an output file. So output will have a machine code. Input will have assembly code. All right, then you're familiar with this. You're familiar with this. Here we go. Input file name. It will read this file in read, and it will open this file in write. Now you have seen that these things automatically close the file when you're no longer using it. So we don't, unlike Perl, we don't have to close them separately. Okay. So you did all that, and then out file that you created here, you have written something. So this is, you call its function and you write in it. And we will look into it in a minute. All right. Then for reading file, this is in file. Okay. So in file we're reading like we did last time, and we are basically, so here, what are we doing? So the input file that we have, let's look into what an input looks like. So we haven't created that, and let's create arithmetic program.s. Let's do it here. Back, and we'll create this file for you. Let me copy this. So this is content. So this is a file. Like you can see, I have comments here, and then I have a label, and then the code starts. So my script will read each one of these lines. It needs to ignore this line. It needs to ignore this line. Right now, I'm not reading labels. All it will do is read each of these. And it say add. Okay, I need to return the opcode for add. It's sub. I need to return opcode for sub. Add I, SLL, SRL, BEQ. Okay. But you will see in a minute what kind of features I have in the procedure. So you're with me, right? All I'm doing is I'm reading that input file here. Let's save it. Okay. Here you go. All right. So all I'm doing is reading that input file and preparing to write in another file. Okay, and I'm going through that. This was the first thing. Do you understand what it's doing? It's trying to skip that line that has this comment thing. Okay, so it's putting, so you can see line dot split. So split is what? I think we did use that. It's basically splits based on this. And then it's gonna remove that, but you're not doing anything. And the next one goes, you're also checking if not line or line bandwidth. If it's not one of these, then we continue on the next line. Okay, so if it not, so skip empty line. So if it's empty line, you move on to the next. You don't do anything else, the remaining. That's a use of continue. And if it contains a label, you don't do anything with it. You just skip, you don't do any, and just go for the next line. You understand that? Okay. So let's say it goes here and it found it didn't do anything here. It goes here. And now what we are doing here is um, is splitting this. So the regular expression that we're using, splitting is splitting what line? Splitting means it's separate things, right? It puts if this one comes into it and it's separated based on comma or white space, right? Then the first token, yeah, it puts everything in token. This is exactly like pose. So 0 contains that add, 1 contain x5, token 2 contain x1, token 3 contain x2. Okay, we are interested in the token 0. That's an instruction mnemonic. And that's where we pass that mnemonic, okay, to the function. And the function returns the opcode which we save in opcode. Okay, let's go into this function. So this function was here, so we get into this function. This is a dictionary that created. It says add this code. We know that all these instructions have this opcode just for a little fun or just to print different things. I'm going to change these. These are not real that I'm making now, right? You know that. So just for 101 110 111 1000. Okay. All right. So you have seen that if it tries to find any of them. So what it does is, so it defines this dictionary, okay, and then it comes here. Look at this. From that dictionary, there is a get. You remember when we look in a dictionary, whatever you input is the key that you gave, and output is the value that is there. So mnemonic.lower means it will, if somebody writes capital ADD, it will convert that into lowercase add, and then it will come here. ADD is not here. Oh, sorry, ADD is here, but for example, BQ is not here. Then I think it will return a none. We will see. Okay, so that's code. Hopefully you understand that. Once it comes here opcode and we check if opcode returned, right? Okay, this is where we are checking. If opcode a value, proper value is returned, then what we do here is we just put an output line. This is a variable we put that we're going to put in the output file. We will write here line number this, instruction number this, and opcode is this, and we'll print it. If it was not in that list, for example, BEQ will happen. Then we'll here skipping non-arithmetic instruction because we are dealing with only arithmetic instructions. And that's it. So you have seen a lot of things here. You have seen how to define a function, how to call a function, right? Then you have seen how to open a file for read and write. You have used the function strip. You have used the function split. And you have used line that if ends with something. And how to put an if on opcode. And a lot of things. Okay, so let's execute this thing now. Let's see what happens. Oh, here you go. So it's skipping non-arithmetic instruction. Add I, BEQ. Those are the two it's a spread, and it has written an output file. And the output file, you will see, click on this. So output file is, I think, this machine code it generated, right? Yes. Machine code you put there. So you see that on line 3, add on 1, 2, 3. So line 3 you have add, and its code is this, add 0, 1, 1 over here. Line 4 and line 5 it skipped because line 5 had added I and ADDI is not there. All right, so I really hope this gives you a very good idea of, and with this video I am kind of finishing the basic tutorial on Python. I think I covered the most basic things, and now we will be using generative AI. Either you use ChatGPT, you use Gemini or Copilot. My favorite is Gemini for coding, so that's what I will be using from now onward. I will not write code myself. I will be using AI to write, and I will be the prompt engineer. Okay, and using that we will build a simulator and assemblers. All right, so looking forward to that project. Every day I will come and I'll share with you my progress, what I did and how I did, and hopefully within a week we can finish this project. All right, that's it for now. Thank you so much, and see you in the next video. Bye.